My first name is Zhongzhou. They got it wrong on my name tag. They got it wrong on the program in 2 different places, which shows that this is too hard. I usually go by Chen. All 3 places are correct, and so just call me Chen. I'm from University of Central Florida. I am in the physics department, but my research is in online learning and physics education research, and Matthew Guthrie is my postdoc who did some fascinating work in the project that I'm going to talk to you about. And because my interest is in online learning, I look at, if these days, if you look into the online learning resource world, you'll see a big boom in online resources. I bet one of those things will be familiar to you. If you have 10 videos, you are a channel on YouTube. If you have some problems, you are an education startup. But amid all this booming education video, there's a big crisis that's looming, which is we don't know how good any of them are. And we have no means to quickly search through them to find the right ones. Now, to determine how good any piece of instructional material is and how students are using it and how much students are learning out from it is not a trivial question. Because let's think about it. You put an assessment and say, okay, after watching this Khan Academy video, for example, I give you a quiz problem, and 60% of the students are able to answer that. That 60% number arises more question, generates more question than it answers, right? Because how many people know that from the beginning they don't even need to watch this video? What about their learning effort? Somebody watching the video for 10 seconds and realized, oh, this is old knowledge, versus somebody watching the entire video while goofing off for the second half of the video, not paying attention. These are very different learning behaviors that leads to this 60%. What about the test-taking effort? A lot of the times we give online quizzes without, especially in ungraded quizzes, without even looking into the test-taking effort. Some students might just be quickly guessing through the homework problems. So all of those goes into the understanding of student learning behavior. On the other hand, if, let's say, we wanted to understand how students are learning this from this video, we look into the data, and we realize 50% of the students watched less than 50% of the video and stopped. That data alone also generates more question than it answers. Why? Right? You really wanted to know, did they lose interest? Are they frustrated? Or did they already know the material? Right? Or not in the mode of learning. They're just not learning. They're just, I used to do MOOC research, and you see these gigantic enrollment numbers. Most of them are just peeking into the course. Oh, interesting, never coming back again. Right? How do you know all these? So to understand how students learn online, I've come to realize that you not only need one piece of data, but you need all 3 pieces: prior knowledge, learning behavior or test-taking behavior, learning outcome. You have to synthesize them together. It's just like our GPS system. We use 3 satellites to triangulate our position on the Earth. 2 doesn't work, 1 doesn't work, you need all 3. How are we able to collect all 3 pieces of data or information on a single piece of learning material? Well, there's my secret sauce. This is my design. Okay, I create those things called learning modules, and the design is this. I ask students to take the assessment before I allow them to learn. All right? I said, you got many attempts. Just try them. You may be able to pass them. All right? First, mandatory first attempt. Then I open up the instruction. This is instruction practice, and it could be a video. It could be a piece of text that I wrote. I feel great about it, but do students learn from it? Right? After they worked through this, they come back, try the assessment again, and the problem bank generates some very similar questions to them. And if they pass, they move on to the next module. So I can create, instead of writing a textbook where all the instructional materials are lumped in one place, then you have a section called practice, and then you have a section called homework, which all of these parts are separate from each other. I have them break down into one module, into smaller modules. Students proceed module after module, and I can have pre and post test every 20 minutes, pre and post test, pre and post test, pre and post test. And I can follow students along the path. Now, another motivation, equally important motivation for me to create this kind of structure is this. I teach in this kind of classroom. I have 250 students, and I constantly feel, well, so this is a really small room for me. I constantly feel that I only talk to about 20 to 30 students in class. I know how to teach best for each 20, 30 student cohort, but I can't teach them all together. I have to clone myself, right? But the only way to clone myself is to be online. If I create those modules, I can start with the easiest module, most basic module, the first thing that I teach in class, and students can say, oh, I know this. Definition of kinetic energy, I know this. They move on. They move on. And some students can start learning here because they missed the class for whatever reason. Some students can start here. So when I wrote the title of this, Melody suggested, you're doing something on personalized learning. I said, it's not really the type of personalized learning that everybody thinks about these days, which involves AI. The computer decides what problem do you get next. This is, instead of artificial intelligence, this is real student intelligence. Students have the intelligence to determine where do they need to focus. Most students do. And we just need to, I just created the scaffolding or the road signs to point them to, hey, do you know this? Do you know this? Do you know this? So all this is wonderful design, and it's been on the blueprint for quite a while before I came to University of Central Florida and met this brilliant team of developers who are developing something very similar to what I had designed. So we immediately joined forces. The system is called Obojobo. They came up with this name because all the other names are registered. And I'm not going to show you screencasts because I am going to show you the real thing. So this is one of the development courses where I create all those modules. And how it works is that you see this one item says number 1 kinetic energy. Come on, Wi-Fi. Load. And I'm the instructor, so I get to be in the preview mode so I can reset everything. Students come in and see learning goals. It's actually a quiz, but I don't want to scare them because students see quiz, they freak out. In this module, you will learn how to do those. Click this button to try these problems. The instruction here is locked. And they say, try the problems. I said, you have multiple attempts. You have nothing to lose, but do try the problems. If you don't know how to do those problems, oh, it's not here. If they don't know how to do those problems, there's an option called let me take a look at the instructions. I put in this option just to tell students, you have the opportunity to learn. And they can do this, and they can do that. I'm just going to skip it. And they say, submit. OK. Submit as incomplete. And they got 0%. OK, no problem. And now there's a button called Learn and Practice. And I'll show you in just a minute that just by doing this, I get some pretty amazing data on how much students practice on those. The majority of students will come in and do all the not-for-credit practice problems, which is something I've never seen before. All right? So this is all the learning. And then the great thing about this, if you ever worked with educational data mining, ever heard about this, you'll know how great this is, because when you require the students to click on a problem to see it, you get a starting time. Right? And then when they hit check your answer, you get an ending time, so we know how much students are practicing. OK, so this is all great. And then they can go into the learning goals and then say, give it another try. And they have 4 or 5 attempts. OK, let me go back to my...
One question?
Yes, please.
Do you have these modules for every session? For every class, every session, you have modules like this?
No, unfortunately. because the system is so new, we had to spend a lot of effort developing the first batch of modules. I'll show you that this study is based on a sequence of 10 modules that covers the content of 2 weeks. We are developing that for more weeks.
That brings me to the second question. When do the students do it? Do they do it regularly or before the exam? Maybe like a day before the exam?
This is homework. Those 2 weeks, I say, the only assignment you have is you can complete all those modules anytime you want during these 2 weeks.
Yeah, so that will be interesting. Do most of the students, they start working on them end of 2 weeks, or they are sort of spread out?
Oh, I have an interesting graph which I didn't put into this presentation because we're still looking into it. You have all across the board. I have one student, there's one point where he does no more than 2 modules per day and spend 10 days doing all those modules. I call this a super organized student. And that student is a male, which is against my prototypes of students. And I have a bunch of students over there who is last-minute procrastinators. And I try to look at the correlation between the grades, and for my very crude analysis, they're all over the place. So procrastinators contain good students who went until the last minute and get everything. I mean, we all have those type of classmates where they brush off the dust on the book and ace the exam, right? And we also have the bottom students in the class. And they can be all over the place. I'm not showing this. Okay? All right. So this is Obojobo, and they are becoming open source. As I am speaking, they're preparing the documents. They're putting this on GitHub very, very soon, and you can scan this QR code. I'll show this towards the end of the, this will be on my last slide, and it's integrated with Canvas. Okay. Now, I was so excited, I got this new tool, and I created 10 online learning modules, 1 through 10. Introduction to the concept of kinetic energy, all the way to a very complicated application of conservation of mechanical energy involving non-conservative work and whatnot. All right, so here comes the data. First of all, you look at the mandatory first attempt, their quote-unquote pretest. And the data shows you 2 populations. This is time they spent on solving those problems. This is under 40 seconds, you see a peak. And then there's this normal students. What this peak is, well, but then before we jump into any conclusion about what this peak means, right? There can be, I call this brief, there can be brief pass and brief fail. Okay, and I can draw it on a circle. This is how much normal pass. This is how much brief pass. It's not showing very well. Brief pass and brief fail, right? It could be guessing. It could be students choosing the let me look into the instruction option. Or if you get a lot of brief pass, then you start to worry about whether they are answer copying or whether the problems are written in such a way that the answer is really obvious without you understanding content. Which one's which, right? All right, so, and they can be low motivation, low confidence, or problem too easy to guess. Now, we shift our focus to the learning stage. Those who failed need to do the learning, all right? For the learning, we also have, a lot of the times, we have a brief group and a normal group. And you have, in this module, you have a brief, normal, and extensive group. So for this analysis, we just broke them into brief and normal based on the time that they spent on the content. And we plot the distribution on another ring, on the outer ring, so you can see for this module, for example, those who did normally on the pretest, normal fail on the pretest, some of them are normal studying, some of them are brief learning, some of them are brief learning, some of them are normal learning. It could also, you could also have multiple interpretations, right? Normal learners could be engaged or low efficiency. They spend more time, but they don't learn as much. Brief learners could be low motivation. I don't care, I don't want to learn this. Or they can be very high efficiency. I just flip through it. Oh, I got it. This is what I did wrong. And let me try the post-test question. All right, which one's which? We have to look at the post-test. Oh, and by the way, it is natural to divide them into what I call engagement modes You have normal, normal. You have normal and brief, normal failed and brief learning, brief, normal, and brief, brief. And at this point, I'm not making any conclusion or interpretation about the nature of those behavior. For that, we'll have to look at post-learning attempts, okay, the post-test. And again, we can divide them into brief learners, which are, for this particular module, they're basically just failing, guessing and failing. The red is fail and green is pass. And then there's normal students. And then for some modules, for example, this one, the harder ones, we have brief, normal, and then a peak around the 3-minute timestamp, which is consistently more passing students. And so we decided we're going to isolate an extensive group on those modules consisting of students who spent longer than their peers and are more successful. Okay, so we have brief, normal, and extensive pass and fail, and we plotted on the outer ring. Now, it's getting a little complicated, but we can now make some interpretations. First, this is normal passing on the pretest, so prior knowledge, they're good. Brief passing, I call this my cone of cheating warning, because if this part is too big, either the problem is too easy to guess, or students for some reason are copying from each other, because you can't do this problem in under 40 seconds. I can't myself. I tried and failed. Those are what you want in your class. This is normal fail, normal learning, normal passing, or even extensive passing. So they have good learning outcome and they're serious on the post-test. So these are the typical, good student behavior, engaged student behavior. Those are the high efficient learners, normal failing, briefly looked at the instruction, spent extensive time on the post-test and got it right. Okay? These are the low initial confidence group. This is brief fail. I want to look at the instruction, seriously looked at the instruction, and then seriously attempted those problems. And so they're just low confidence initially. And then we have this disengagement band, which is brief, brief, brief. I'm making a random choice, flip through the instructions, making a random choice, or answer copying again. So we can put those 10 modules together and look at how the behavior changes when the thing gets harder and harder, right? First, we have those 4 modules that are pretty similar to each other. You can see that there are very few guessing, okay? No guessing correct. Very few guessing fail, and essentially no guessing correct on the pretest. I'm not going to go detailed in these graphs, but the message is that these people who, on those modules, those people who spent not enough time learning are having worse learning outcomes, okay? So those people, if I can send a message to them, I will send a message to them saying, you need to spend more time, right? Because your peers who are spending more time learning the material are getting better outcomes. Very different behavior on this module 3. You have a lot of passing, but a large fraction of brief passing students, significantly larger than its neighbors, okay? I think what happened, but actually their learning outcome is not so different from the rest, okay? Post-learning is pretty much the same. What was happening was that these are all more or less conceptual modules. I throw a math-heavy module inside it. My hypothesis is that it scared people. They're not ready to do this problem. So I have an exceptionally large guessing or just answer copying population. And maybe that problem is designed in such a way that it is too easy to guess. Okay? This is what a very easy module looks like. Everybody passes. Almost everybody passes. Even the brief learners passes. And I can't I can't find a cheating group because everybody is spending so little time. So this is too easy. I need to fix that next time around. This is a hard module. This is a really hard module. If you look at it, these are extensive problem solvers who fail, right? Extensive problem solvers who fail. The interesting part is, despite this module being so hard, there are very few guessing and passing or guessing and failing students. There are very few guessing students on the pretest. They're all trying it and failing. What this does to the students? The next module, you have this gigantic group of people just giving up. This is too hard for me. I crush, on the next two modules, I feel I crushed their confidence. However, if you look here, you find another group of students. Of course, you'll find a group of serious students here. Okay, they're really trying, learning, getting it right. And you find a group of students who are brief. This has a big brief learning group, and they're doing just fine. Okay? My implication of this is that although a group of students fail on this module, most of them, some of them got frustrated and started to disengage from the learning process. Others figured this out and transferred their knowledge, because these two modules talk about really similar problems. This is just a little bit more complicated than that one. They transferred their knowledge on this module and also in this part. They learned it, and they don't really need the instruction. And on those two modules, you see pretty much the same thing, which is those brief learning groups. This is the normal and brief learning group, those guys, are having better performance, are having equal performance, and are equally serious. This is non-brief, and this is extensive students, are having similar performance as those students. Here's the last module, something I call the last module effect, because when you are at the end of your struggle and you look at this module, it's harder than anything else. What students will say is that, oh, I just want to be in this class. B is good enough. Have you ever had students tell you that? This is B is good enough here. I call this my velvet cake of disengagement. Brief, brief, brief. I just guessed through, okay. An abnormal increase in disengagement. And the hypothesis right now is that because this is the last module, and I'll be testing, if I add a module later, do I extend this last module effect or not? Or is there something really wrong with this module? Okay. What do we learn from that? Each learning module have very different characteristics. Some are too hard, some are too easy, some destroy students' confidence, and some will split the population into two opposite groups. Excuse me. So really, as an instructor, an instructional designer, next time I write, I'm not writing chapters anymore. Nope. I have better resolution. I'm writing 20-minute learning modules and testing them in this situation, how good each of them are. Students, as instructors, I hear multiple times that people tell me, oh, my students are lazy, or my students don't work, or this class is really strong, they work all the time. That's not true. The truth is that students make deliberate decision about engagement all the time. If we look back, each module is different. Their confidence gets boosted by an easy module, that gets destroyed by a hard one. Some of them decided to disengage, some of them decided to stick on. This is a very complicated pattern which requires much more study into it. And mastery learning design is really the most sensitive probe into student engagement that I have seen so far. And it just opens up a lot of future possibilities for research. Now, let me make some general comments about mastery learning design. All right? In a traditional course, everybody moves at the same pace: instruction, practice, assessment. I feel sometimes I'm not an instructor, I'm a bus driver, okay? Because my passengers are students, I'm the driver, because I have a bus schedule. Today we're going to do this, tomorrow we're going to do that. Regardless of if you understand the past one, regardless of whether you have military duty or a hurricane torn your house off, we're going to do that next week. That's what we're going to do, okay? I'm the bus driver driving a lousy bus because my passengers keep falling off and I let them run to catch up. In this bus driver's scenario, if you wanted to increase flexibility and effectiveness, you increase the cost, right? You go from train to limo. You decrease instructor to student ratio. And that obviously doesn't work. Higher education is too expensive already. The solution may be to give the road signs and road maps and GPS to our students and let them drive. And let them do the mastery learning, which, by the way, was a concept that was proposed by Bloom and Keller in the 1960s. But the poor guys back then were doing it by hand and hand grading all the paperwork, and they got really overwhelmed. Now we have computer technology. Let's not replicate the dinosaur again online, which is the traditional way of course designing. Let's do online mastery learning modules. And because it provides such a rich data, we have the GPS functionality to track the position of students. I call this a GPS of learning. Not only can we let the students drive themselves, we collect traffic data on where they are stuck, which allows us to transform ourselves from drivers to city planners. And I have a dream, and I want to make a proposition to anybody here from Helmsley Foundation? Oh, unfortunately. I want to, let's not create our own version of the course by ourselves, right? We have this modularized structure. Let's collaborate. Institution A, Institution B, and Institution C, where our students are at different levels. Let's create a sequence of those learning modules. And we can have extensions. We can have, these students are not good at vectors. Let me create this vector module that are most helpful to those students so that each student distribution could benefit from the whole sequence of modules. And by the way, if we have transfer students from one institution to another, they just transfer from one section of the module to another section, it won't be such a cultural shock. So let us collaborate and become city planners. And with that, I end my talk today. Thank you, and welcome questions.